Hey everybody, y'all probably seen a previous video I did on this inverter. Um, it arrived pre-broken right down here. See that capacitor? And I'm going to show you a little quick clip out of the previous video so you'll see what I'm talking about. So just look back right here and let's go to where this problem was diagnosed. That. These are all the parts that were loose floating around inside this inverter. Now, would this inverter have just worked if I took these parts out and went about my merry way? Well, I thought, hell yeah, let's get ready to package it back up, put some battery power to it. And then I go, oh, hey, the hell? That doesn't look good. Okay, now, we ordered the parts in, and the guy selling this, you probably, if you go look at that first video, I laid it out pretty good for him. So we ordered the parts in, and we got new capacitors. So the new capacitors now, the 4.7, I believe they are, yeah, 4.7. They're going to go in, and we're going to finally get a chance to test this. Now, the components, they're good graded components. But if you look at the bottom of the inverter, they, component-wise, quality's pretty good. Their assembly is just shit. So it's the best way I can put it. Just straight shit. I tried my best to love the idea of one of the cheaper 2,000 watt true sine wave inverters. The solder jobs are just sloppy. I mean, just sloppy. And the way that they put this together, a lot of parts were missing. This screw was missing. One of these standoffs were missing, so I had to, luckily I had some material for these, and I glued these in. All right, so what we're going to do now is we're going to pull the old capacitors off. There's the two of them down here, and we're going to replace these because this unit has never been fired up yet. We have a pair of old restored batteries that are sitting here right now. This one was restored. It's about a 12 or 14-year-old battery, and this one right here is about a 7-year-old battery and is also restored. So we're going to be using those to power this thing up and run a few things using the watt meter. So let's get this on here, and I'm going to show you hopefully this thing powered up and handling a load and good voltage and all the other information that you're going to need on these. But I believe the inverter, just from components inside, are good inverters. I believe they are, and I'm willing to give this one a chance. The seller did make good on this. He knocked off a significant amount of money, way more than it took to deal with the parts. I'll flip this over. I've got and we're going to get it ready, and we'll have these parts replaced here in just a second. Now, I've just got the first two removed, and I've taken a little small bit. Now you can get a box of these numerous sizes, and the smallest one in the kits are perfect because you can hold it and twist it with your fingers for cleaning out where the legs of your fittings will go on a board like this. I believe this one here is like I think it's metric 1.25 millimeter or something. So there's a good way of doing it right there. It's a nice, easy, clean shot to do your other fitting and put them in. Now, working with two more capacitors, I already set the legs up to match the holes. And unlike the previous company that made this inverter, they left the legs totally straight and just jammed them in, which is what broke away the connection on the capacitor. So when you replace capacitors that are in the same sequence like this, that are set up like this, just go right ahead and replace all of them. You do it right the first time, and then you don't have any issues whatsoever. So I'm going to get the rest of the soldering done on it. I'll get the legs trimmed off, and we will get this thing flipped over, and we've got the power ready with a standard battery disconnect, and we have it to where we can control power on and power off for the power going to here. So right there is my two connectors for negative and of course positive, And we're going to first power this thing up sitting on the table in the right position, just to see if it smokes. I don't want to go through all the work and get it back in this case, and I'll film that as we do it. So let me get this finished right here, and we'll have those two new capacitors ready to do their job. And we've also done some other minor things in here, including some gluing of things to keep them from moving around. That is one of the things you want to check on every one of these. But me personally, I open up everything made in China just to see what's in them. All right, now we've got the capacitors in and everything is laid out kind of safely. And you'll see down here where this is for the reading the amperage and watt draw that's going to be on this unit. I put a little glue in that because it was pretty loose. The Torad, I put a little bit of glue in around a new strap because the one was broken. And then right down there was a screw coming through this voltage modifier circuit that was touching the transformer. So we didn't want that, so we trimmed that off, and we've got the power hooked up, and I have the key to whether or not it's going to blow up. It's going to run. So power switch is off. Get all tools out of the way. Fire extinguisher down there ready. You know, it is made in China. So let's see what happens here. There might be a slight arc over here at the battery. There's a little arc at the battery. Or look, I don't know if you heard that pop or not. Now we can't run it long like this out of its case because the case is created for ducting purposes. But we're going to go ahead and get the meter ready. Get it on 200 volts, and the wide blade on a polarized plug is of course the negative, the common. So let's get that in there. And the narrower blade, shorter blade, is the positive. So we'll get that all in there like that. And now we're going to risk life and limb. Everything else I have gone through and checked. So let me get back here where we can see everything. And we have a successful fire up. It is showing, it's very bright. I don't know if you can see that. I'll try to get that in there where you can see it there. 13.1 volts on the battery, 60 hertz, 119 volts output. And the multimeter, get it where it's holding good over there. It's not holding it here very well, so. And this is also on search mode, so you'll see it jump a little bit. And right now it is pinned 120 volts. They're in and out of search mode, see? So we're going to look at that, and we're going to go ahead and hook up some power or something to run off of it. And I'll go ahead and power it back off. And we'll plug something into it. We're going to start with this watt meter right over here. So let me get that hooked up. We'll do a very short run. Didn't get no heat. Nothing got really warm or hot. We look okay. No MOSFETs or diodes got too hot, so there's actually no real heat created yet. Let's get something hooked up. All right, and a pre-test on a heater, this heater right here, it has 3 heat levels and fan. We got the fan of 15 watts, level 1, 582 watts. They do take a few seconds to stabilize. Level 2, 850 watts, and level 3, 1355 watts. So this is considered a 6, 9, and 1500 heater. A little underrated. So heat all the way up so that it will kick on, and my current shop temperature is about 63, so it's no problem getting this to kick on. And we're about ready now. Now I'm telling you, I cannot run this very long, so if you want to comment something about how long I ran it, don't. It's not very pointful. You can't run these long without having it set inside to where they duct their heat out. Otherwise I'll be burning up my MOSFETs. We don't want to do that. And on we go. Over here we have 118 volts, and our hertz are very nice, 60. Very good quality there. And we're going to kind of run back and forth through these and see what we got. Now there's the wattage, and I'm plugged in, so you'll see that everything here is as claimed. And we're going to turn this on fan. See that in here? Here running. All right. So right now we're pulling about 13 watts of power. Okay. Now we're going to check for any voltage sag. Pretty consistent. All right. And we'll go back to watts over here. And we're going to kick on level 1 heat. Let's see if this thing balks on us. All right, 150, 309, 567. So fairly close. And let's see if we have a voltage sag. Not terrible. Actually pretty good, pretty stable. Okay, so go back over here to watts. And I'm going to give the inverter a little cool down time right quick because I don't want to mess up my inverter. Okay, now I gave it couple minutes there, and now we're going to go ahead and switch it all the way over to the third, and we're going to be putting out 840, so that's very close to the 850. And voltage sags a little bit. Let's see what our voltage is. 116 still. So let's see how accurate. I don't know if y'all can get a read of that. It's showing 11.2 volts in the battery, 838 watts. Pretty damned accurate. Now this is the first time I've seen one this accurate. So we'll go ahead and shut this off, give it a chance to cool down because we put a pretty good sized draw on it. And the batteries right now are hooked up going back to my big mess wall there because I don't have enough amperage for what I'm doing. And anybody who buys one of these, I want to give y'all that heads up. If you don't got enough amperage, they're not going to work right. You must realize when volts drop, okay, to supplement amps, more amps will be drawn as a result, and that's how you burn a lot of these up. So you need to always keep that voltage up as high as possible in the 13, 14 range for the most efficient and full power use of these. The way to do it is put in like 4 batteries instead of what I have, just 2 old beat up batteries. This one's only 74 amp hour and this one here is 85. Not a lot, okay? But for the purpose of the test. Now, we're sitting here nice and pretty at 118 volts. And over here, it's also claiming, let's see if I can get it. Yep, 118 volts right there, okay? So our voltage is at 12.1 and gaining because it's pulling back from the bank again. And we'll fire up that next full load here in just a second. Okay, after allowing the batteries to come back a little bit, they're up to about 12.6, and the inverter to cool a little bit. We're going to go ahead and get the full power pull with this heater, which would be in the 1350 range, okay? So let's go ahead and see what we've got. I'm going to go ahead and let voltage stay on there first, and we'll put it on full pull. Hopefully she don't scream at me. Voltage sag down to 111. That's still within the 105 to 125 volt range. Good, nice. 1249 watts, 1252. So it's pulling 100 watts less due to the fact that the voltage sagged. You see right there, and pulling 11.2 amps AC. So it looks like the whole thing is functioning as they advertise now. And there you go, 10.8 volts, 1256 watts. And the meter, unusual for a Chinese one, is actually accurate. So let's go ahead and run this back. So at about half it's rated, it pulls very nicely. And down to 500 watt, now I'm back down here now and switch first heat level. And then I will put it on fan. There we go. So Now I can adjust this right down here to bring that voltage up just a little bitty bit. I can bring it up to about 122. And don't worry, anything from 110 to 130, any appliance will run on it, as long as your hertz, this is cycles per second in your sine wave, remains at 60. So in other words, your volts can be 140, and something like a grinder, it'll still run great. It ain't gonna hurt it. In fact, it'll run cooler, because the higher the volts, the lower the amps, and it's the amps that make the heat. So you can run a grinder at 140. Volts go up, amps go down. Volts go down, amps go up. That's how it works, Ohm's law. If you believe that's impossible, well, look it up, man. They used to run electric motors on 140. Used to have a volt booster for them to make them last longer. So don't let nobody bullshit you. Here it is. You've seen it. It ran. That clip of my other video. Look at the bottom of the video for anything I might have used. And look at the clip of my other video, the link to it, and the clip at the beginning. You'll see how we got here. And now we've got a working inverter, and it cost about $3 to fix it. One thing is, you buy Chinese and you don't speak good English, you better speak good parts buyer, because that's what it's all about.